I'm not sure if by your silence you aren't completely comfortable with what we call circular definitions of trig. I know everybody's comfortable with classical Greek definitions of trig functions, but again, when we first started talking about this, as soon as you extend the angle bigger than 90, Greek definitions of trig functions work for angles up to there because they're less than 90, but as soon as you go past that, you can't have a right triangle with that angle in it, so you got to extend your definition of how you're defining the trig functions. If this point is anywhere around that circle, the sine ratio is the y-coordinate divided by the radius. The cosine is the x-coordinate divided by the radius, and so on. The tangent is the y divided by the x. If you want what the reciprocals are, if sine is y over r, then the cosecant, its reciprocal, is r over y. If the cosine is x over r, then secant is r over x. And if tangent's y over x, then this is x over y. All right. The reason your calculator doesn't have these reciprocals is because for most purposes you don't need them. Number one, because if you're ever trying to find missing sides like you do in grade 9 and 10, you only need these three to use, because as long as you have a trig ratio that relates those two sides, you're good. And if you ever want to graph these or work with these, instead of punching in secant, you can just put 1 over cos of whatever you want. So you don't really need these ones. But nonetheless, we're going to look at them as functions in grade 12 here. This, before you start looking at graphs, I want to just look at evaluating these expressions involving these things. So we've got this kind of thing, and if you had a button for this on your calculator, it'd be a piece of cake. We wouldn't need this section here. Since you don't have a button, likely, unless you have some fancy new calculator that has it, I don't know if any do, maybe they do. Since you don't have a button for that, you need to think about how you can get your calculator to work this out. Either how you can get your calculator to work this out, or how you can get your brain to work this out if you're asked for exact values here. If you want to evaluate this, well, first of all, let's try and remember what the word evaluate means. Think about how that word evaluate is different than if it's something said the word solve. How's the word evaluate in math different from the word solve? If something said solve, what would you expect to be after it? In grade 8, let's think of grade 8 questions. If there was a word solve, what might you expect to be after it? As opposed to if something said evaluate in grade 8, what might you expect to be after that? What's the difference? If something said 2 squared plus 3 times 4, where would you expect that to be? Which place? Where is this? Go here? Does this go here? What's the difference between the word solve and evaluate? Yeah, solve has to have an equal sign in it, right? This thing doesn't have an equal sign. You could ask someone to evaluate that. Evaluate it means work it out and figure out what its value is, right? Value. Word value in there. Find what the value is, right? I'm not going to insult you by doing the grade 8 question, but what is something with an equal sign in it here, and what other thing does it probably have to have? If it said 2 plus 3 equals 5, is there any solving to do there? Not really, right? What else do you probably have to have in it to ask somebody to solve it? Yeah, a variable, right? Now, I'm not trying to insult your intelligence in implying that you don't know this, but you need to remember these things as you do this, because when it comes to grade 12 and things look more complicated, people tend to start to forget what they're actually doing, and they start putting in equal signs and variables when they're not there, right? When you're asked to evaluate these things, don't start saying equals this, and then, oh, I have to do, cotangent inverse and all those sorts of things. Don't start to treat it like an equation when it's not. If you want the secant of this, I could put an equal sign here and write another expression that it's equal to, but I can't start putting in variables, and I can't start saying, oh, I want to divide this by 3 and do that sort of thing. What is this equal to? Secant of that, by definition, what's it equal to? It's a reciprocal of something. Which one is it the reciprocal of? Cosine. This is the same as 1 over cosine 3.45. If you're in radian mode and you put that on your calculator, you'll get it. It's not hard if you know the definitions of those things. So if you're in radian mode, you can do it all at once. 1 divided by cos 3.45. Or you can do it in 2 steps, right? You can do cosine of 3.45. You can get the value of that. And then you can do 1 divided by that number. I'm just going to cheat and put answer here. Right? 1 divided by that number gives you the same thing. Notice that when cosine is negative, secant's also negative. If a number is negative, its reciprocal is negative. So if you want to know where sine or cosecant, secant, cotangent are positive and negative, it follows, their corresponding functions. Why is this one negative? Why is the cosine of 3.45 negative? What quadrant is that angle in? How do you know it's in 2? Well, just looking at this number, how can you tell from the number? Like 3.45, how do you know? I mean, in your mind, what are you picturing? You're thinking, okay, is it there? What quadrant does it end in? Does it stop here? Does it keep going? I can tell you that it ends here. How can how can we know it ends there? Yeah, because that pi, right? So in your mind, pi, I think some people forget that this is approximately 3.14. So 3.45 is a bit past that, right? And it's going to be here, and cos is negative there. Actually, I guess, you wouldn't have to know that because cos is negative on both sides over there. Anyways, whatever this was, negative 1.04 or something. Okay, whichever way you do it there, I guess 1.05. If you're doing it to 4 decimal places, 1.0495. It doesn't matter if you're given a fraction like this. You do it exactly the same way. Reciprocal of whatever is its corresponding function. I'll leave that one for you to do. The answers are down there to check to make sure you're doing it right. This last one here requires a bit of explanation. And the first part of the explanation is mathematicians tend to be lazy people. So for some reason they've adopted this as the notation for this makes it different here, this little squared in there. What this means, really you can do this if I tell you that means the same as if it said cosecant of 9 pi over 7 squared. That's what it means. But at some point somebody, I guess, decided, you know what, I'm tired of writing these big brackets all the time. I really want to stop writing these big brackets. What could I do? I could just stop writing them, right? What happens is, what's the problem if you just stop writing those brackets if you write cosecant 9 pi over 7 squared? What's the problem with that? The squared, who knows where it's on, right? Is it just on the pi? Is it on this angle? Like, do you square the angle and then find the cosecant ratio? Or is it the whole thing squared? It's unclear, right? So for some strange reason, instead of somebody saying, well, we should just keep the brackets there, somebody decided, oh, I know what I'll do. I'll put this 2 over here because then it's right next to the cosecant ratio, right, the word. And so people will know that it means the ratio squared, right? Not the angle squared, the ratio squared. I'm not a fan of this notation, but that's what people use. It means figure out the ratio first and then square it, right? That's what you just have to, I would say, anytime you see this, write it with the brackets and the squared outside there. It's not the angle squared, it's the ratio squared. Okay? Ratio squared, not angle. Not the value inside, okay? So you have to do some thinking about that on your calculator. I'm not gonna do that one on the calculator for you, but question? Sure.